Hello and welcome to the Daily Space. Today is September 6th, 2018, and I am your host, Dr. Pamela Gay. Today, being a Thursday, we're going to have a special episode following this episode of Daily Space, and that is going to be our learning space. Today's guest is going to be Martin Roos, and he's going to talk to us about his amazing experiences as a filmmaker covering the Venus transits. Now, before we get to Martin and all the amazing things he's done combining videography, filmmaking, and science, I'm first going to bring you a quick roundup of some of today's news. It is a light news day, as Thursdays often tend to be, but we do have a few interesting things to bring you. The first is going to be a story of how students, or in this case, one particular student, was able to discover one particular planet that statistically is super interesting. This planet was discovered examining the light curves coming off of the Kepler spacecraft, and it has the ever so exciting name of Wolf 503b. This means that it is a planet orbiting the star Wolf 503, Wolf being the name of the survey, and 503 being kind of its license plate number within that survey. Now, the reason that this particular planet is of interest, well, first of all, it was found by a student, like an undergraduate student. How cool is that? To be an undergraduate, accepted into graduate school, and while you're getting ready to start working on your master's thesis, you just find a planet. But beyond that, this planet has very particular characteristics. For reasons that we can't quite explain, there is a gap in the size of planets between one Earth mass and, or more, between 1.5 Earth masses and 2 Earth masses. The graph that I'm showing you is labeled in French because the student is from a university in Montreal. What these axes say is the mass of the planet along the bottom x-axis in Earth masses, and the number of planets discovered per 100 planets that have that particular mass. So for instance, roughly, let me get somewhere interesting. If you look at the 3 Earth mass, roughly 3 in every 100 planets are going to be 3 Earth mass planets. Now, Wolf 503b is right at that very edge of this strange gap in the masses that we're discovering. It is, like so many of the planets we've been able to find, orbiting on an orbit smaller than Mercury's orbit. Now, we're hoping that further follow-up on this particular object that we don't know anything about the surface of, which is why it appears as a blue ball in this diagram. We're hoping that as we're able to observe this, ground-based telescope spectrometers are going to be able to give us more and more details about what is the surface like. Is this a super hot gassy world? We know it's not an ice giant like Neptune, but it probably can't have the same kind of atmosphere that Earth has due to the temperatures that it's experiencing. Anyways, this is just one more world that is going to help us understand all the worlds and the continuum of features that they have as we look out across our nearby galaxy. Now, moving on, this is one of those things that falls into the politics of astronomy. The graph that I'm currently showing you, it's one that kind of should break your heart. It shows the percentage of individuals graduating with a bachelor's degree in blue or a master's degree in red that are underrepresented minorities. So these are people that may be black, may be Hispanic, may be of African origin, well, that's black, people that are of a racial minority within all of these different fields, from computer science on the left to geosciences on the right. And it turns out that in our field of astronomy, at the bachelor's level, only about 10% of our population is actually a racial minority. And then when you go over to the PhD level, we're more at 5%. Now, the number that is hanging out for no obvious reason, the 91 above computer science, the 6 above astro, that number represents exactly how many PhDs would be needed to bring the number of people graduating at the bachelor's level percentage-wise to match the number of people graduating at the PhD level. Now, what this is telling us is in astronomy we don't have that many PhDs. And all it would take is just 6 additional people per year graduating with a PhD that would bring the percentage total at the bachelor's and the PhD level to be the same. Now, it's kind of frightening when all it takes is 6 people to make that big a difference, to go from, well, the 5% up to the 10%. That means that any given year we're graduating, well, this is a factor of 2 difference. It means that we're probably only graduating 12 minorities in all of astronomy with a PhD. So here is hoping for change, and we are hopeful. The reason I'm bringing this up today is the American Astronomical Society has been awarded a grant from the National Science Foundation to work specifically on trying to understand what are the reasons that so many minorities leave astronomy or fail to continue in their astronomy education. This grant will not only work to understand what are the factors that cause people to not keep going, what are the factors that cause people to leave later on, but will also work on defining ways to fix these issues and introduce new programs, no matter what it may be that's needed, that will help rectify these problems. There's been a lot of efforts put into trying to attract children at the K through 12 level to enter STEM fields, programs to get women involved, programs to get minorities involved, but it's looking more and more like the problem isn't getting people interested. People are intrinsically interested in science. The problem is keeping them. And now we need to find out specifically what are the real reasons that people are leaving. No more guesswork. It's just going to be science, in this case, social science. Now, in a bit of more uplifting news, we have a new award in the physical science, mathematical science, and life sciences that is being given to individuals that make the kind of breakthroughs that change how we see our field forever. This award is, well, named the Breakthrough Award, in this case having a name that exactly fits why you're getting the prize. And this year's prize for the physical sciences goes to Jocelyn Bell Burnell, shown here as she was as a graduate student. Her work discovered the first ever pulsar. Now, it wasn't just that she went out, she used a telescope, and she discovered some cool stuff by accident. It was she built the telescope. And after building this radio wave, was using it to study our sky and came across this weird pulsing radio phenomena that could only be explained as the ticking of a rotating neutron star that, due to a misalignment in its rotational axis and its magnetic field, was able to, lighthouse style, pulse, well, radio waves towards us. These are the pulsars. Now, much to pretty much everyone's frustration, the Nobel Prize that was awarded for this discovery did not go to, well, Dame Jocelyn Bell Burnell. Instead, it went to her graduate advisors, as has too often been the case in science. Now, as she continues to be a working scientist, she's finally getting the full recognition of just how amazing her discovery was that she has always deserved. And we are quite pleased to recognize Dame Jocelyn Bell Burnell for being this year's recipient of the Physical Sciences Breakthrough Award. Now, in one final update, I just want to remind everyone that tomorrow, following the Daily Space, we are going to have Andreas Plazas, who will be hosting tomorrow. He's going to go from hosting the Daily Space to, well, bringing you coverage of a NASA press conference on the Dawn mission, which has visited both the inner dry asteroid Vesta, which you have helped us map out in CosmoQuest, and well, Dawn went from there to visiting the largest asteroid and one of the wet asteroids. This is the World Series. By studying these two large, well, rocks in space that were formed in two very different parts of our solar system, Vesta being dry, Ceres being wet, we've had amazing insights into, well, the early way our solar system was evolving. It also gave us insights into the collision histories of these objects and just what kind of, well, a beating an asteroid can take without falling apart. Tomorrow, on Dr. Andreas Plazas will be providing commentary and answering your questions while bringing you live NASA's press conference on this amazing mission. Following that up, we will have over on YouTube on the Astronomy Cast channel our season 13 premiere episode of Astronomy Cast. So we're going to bring you 3 hours of science, starting with the Daily Space at 1 p.m. Eastern, followed by our coverage of the NASA press conference on the Dawn mission at 2 p.m. Eastern, and then Astronomy Cast coming to you at 3. You can keep track of everything that we do through CosmoQuest and our sister programs by checking out wshcrew.space. The weekly space hangout crew is, well, they are our volunteers, our supporters, the people who help, well, test out everything we're doing and give us support to keep doing what we do. Check out what they're doing and they will keep you up to date on everything we're doing. So, I am going to take a couple quick questions, but I want to get Martin on and we'll do a prolonged set of questions after the interview with him. So if you have any quick questions, please go ahead and drop them in. So I see Dat Dolphin is asking, how important is the discovery and monitoring of pulsars in relation to timed measurements? I'm not quite sure what you mean by in relation to timed measurements. We are actually able to measure the rotation of pulsars down to millisecond levels. And I apologize for the overrunning of the chat on the screen you're currently seeing. I am going to be working on getting that fixed. Let me get it so at least the most recent stuff appears on the screen. So Magnus Thelmer, I hope I pronounced your username correctly, is saying, so most planets are somewhat in between Earth and Neptune in size, but none of the planets in our solar system fall within that range. So not quite. Let me bring that graphic back up. So it turns out that the largest number of planets per size comes for objects that are essentially 2 to 2.5 times Earth mass. These are all of the ice giants, except they're probably not so icy considering they're being found snuggled up next to their worlds. Now, looking at this, if you integrate between different size bins, for instance, the total number of things between 1 and 2, the total number of things between 2 and 3, 3 and 4, you're going to notice, first of all, that the spacing on this graph is not constant. This is a weirdly skewed graph. It's not quite logarithmic. I'm not quite sure what they were doing other than fitting it all on this graph. But if you look at it closely, you'll find that there is the largest total number between 2 and 3 Earth masses. Okay, moving on to see what other questions. So Hanny is asking, when is the series finale? I'm not sure. But as I said, I'm going to do a prolonged question and answer at the end of our interview with Martin. Before bringing him on, I'm going to do a quick audio check. And so I'm going to say goodbye for the Daily Space and start transitioning over to Learning Space. As always, the Daily Space is brought to you by you. We are sustained through your subscriptions, and every bit really matters. We are a production of CosmoQuest, which is produced in collaboration between the Astronomical Society of the Pacific, the Planetary Science Institute, and Youngstown State University. If you give us a follow, follows are free, and you will be notified every time we go live with any of our various shows. Thursdays we have Learning Space, Wednesday and Friday. In addition to Daily Space, we also have Astro 101 taught to you by Dr. Matt Richardson. We also have Sunday Science brought to you by Annie Wilson, who helps you understand where planetarium shows come from and the kinds of graphical skills that go into making them. We also do a variety of coverage of spacecraft launches and NASA press conferences, so you never know what surprise might be lurking one "We're live" announcement away. So I will be back in just a moment, so don't go anywhere. Stay tuned for Learning Space, launching momentarily.